Good morning, guys. It's Morgan from RacerX Performance Tuning, coming to you from Atlanta, Georgia, where it has actually snowed here for the first time in 4 years. Up first, I want to thank each and every one of you as we recently hit a subscriber milestone here on YouTube. I mean, let's face it, this is quite a niche audience and a channel that has only grown organically over the years with some very specific content. So I appreciate all of you who have subscribed, and it keeps me hungry to create more tuning content for you this year. So today we're going to talk about two of my favorite features in Haltech NSP. One of them is flex fuel tuning options, and the other is 3D maps. And we're going to see how we can use those together or separately to affect two different methods of running flex fuel in Haltech. So let's say you decide to make the move and you want to go to E85, but you also want at times to run pump 93, and you don't want to drain the tank between your ethanol and your pump 93 octane, right? So in which case this flex fuel sensor is going to allow you to put whatever you want to have in your gas tank and run on that, and your car will run just fine regardless of what you've got in there. So first thing you're going to do is, let's say you're going to go under sensors, if you installed your sensor, and find your flex fuel compensation temperature sensor, and here you're going to configure it accordingly to whatever wiring you have set up for your sensor, where you've wired it into your Haltech. So from there, got a couple more things to do. I'm not going to go into too much detail about all of the configuration for a flex fuel sensor, but you're going to want to come in under fuel temperature, under diagnostics, and enable both the temperature raw minimum and the temperature raw maximum. And then under flex fuel composition, you're going to set up to your thresholds, right? So enabling your thresholds here, a maximum RPM threshold, a maximum load, and then same thing under your diagnostics, both enable each of these. This is going to allow you to provide a little bit of a safety feature in case your flex fuel sensor decides to basically take a crap on you or something similar to that. In general, it's a good rule to put your flex fuel sensor on the feed line rather than the return line. But if you put it on the return line, then these options allow you to kind of essentially put a clamp on things. So when you're in a high flow fuel rate scenario, basically you won't let the what we'll do is keep the readings of the ethanol consistent. So you also have options to set up any DTC severity levels that you might want to, and act accordingly on those if you want to do something with that when it occurs. So with the sensors set up, we can now go over, let's actually go over here to main, and we can close up sensors tab. Now we go under fuel tuning. And here under fuel tuning, if you haven't already done so, you definitely want your tuning method to be volumetric efficiency. This is the magic that uses all the math that allows us to tune fuel pretty much one time and not have to tune it again. And generally, if you've got your injector scaling correct, and you've got your dead times correct, and you use a very standard volumetric efficiency fuel map, you're going to be in the ballpark right from the get-go. But anyway, that's a story for another day. Under fuel type, now you can select flex fuel. Now before you might have been on petrol, or you might have been just running ethanol with a specific ethanol percentage that you've been running. But now you can get to choose flex fuel as your option here. And when you do that, I mean, the beauty is that this is going to allow Haltech to do the math for lambda based on the stoichiometric ratio, and it's going to provide the proper fuel mass. So whatever percentage of ethanol is in the tank is going to determine the stoichiometric rate. Okay, and the last thing we're going to need to do, let's again close up sensors here. We have two corrections that we have enabled for us, or that we will need to enable for us now. So under fuel tuning, we've got our standard corrections here, and we want to add this one. If it's not already enabled, enable fuel compensation correction. And under ignition tuning as well, you've got corrections, and similarly here, you want to also enable fuel compensation correction. This is going to allow us to use that ethanol sensor to make some changes to our fuel and to our ignition based on the composition of the ethanol content. So one of the things I just genuinely love about Haltech is its extreme flexibility. So right now we're going to talk about two different methods of tuning flex fuel that you can use in Haltech. So with the first method, generally the rule of thumb is first you do all of your fuel tuning for your petrol. So you put in your pump 93 octane or whatever have you, and you go about setting up your target lambdas, and you do your base fuel map, which is your VE map. It should be somewhat similar to this. Go and do your fuel tuning, go and do your ignition tuning, go do your boost tuning, do all those things, and then you are done with ethanol. With petrol. So once you're done with your pump 93, now you're ready to kind of change gears and start to use these things called corrections and compensations for the ethanol content. So earlier we were talking about it when we went in under fuel tuning and we looked at corrections and we added this fuel compensation correction. So we look at what that is. Specifically, you have a fuel compensation correction scaler. This is going to look at the percentage of ethanol that you have in the tank. So the sensor is going to read and say, well, guess what? I've got 85% ethanol, I've got 70% ethanol, or I'm running pump gas, so I have 10% ethanol or less. This scaler is going to basically take us and use this value to determine how much of other tables we will interpolate between the corrections that we're going to apply and the base amount that we already have from our pump 93 tuning. So essentially you want to set this up like this. You can come in here and go to table axis setup. You're going to have values of maybe 0 to 100. This is the ethanol content that you're going to have in the tank. Generally, once you're at about 70% ethanol or more, it's going to be about the same. When you're at 10% ethanol or less, that's your pump gas. So basically you set that up like that, close it up, and then when you're at 70% ethanol or greater, you can use 100% of the scalers that we're going to use, or the corrections that we're going to use. And if it's at 10% ethanol or less, the pump 93, then we're going to use 0 of the corrections that we would consider using. So with those values, let's say if we had, like we said, 70% ethanol or greater, we'll use 100% of the corrections and compensations, and under 10% or less, we use 0 of those. And in order for the flex fuel sensor to work and use its magic, when we got a mixture of pump and E85 in our tank, we basically want to just linearize between these two, and this is going to be the percentage of interpolation that it will use when we work with these correction tables. So similarly, also down under ignition tuning, you've got another scaler. That's the fuel composition scaler down here. And we're going to set it up the same way. There's really no reason to set these two up differently. But if you had to, or if you need to, or you had a reason to, you could do your ignition composition corrections differently than your fuel. But nonetheless, you would normally set these both up the same. Now, here comes the good part. Let's say, given that we've already tuned our ignition fuel map, our ignition timing map, right? We did our timing under our pump 93, and now we only need to make corrections based on what we want to do when we've got, let's say, 100% of our ethanol request, which is 85% or 70% or better. So down here in the fuel composition correction table for ignition timing, this is where we can add more timing based on how much ethanol we've got. So let's say we're running E85 and we know that we feel pretty good about maybe adding 12 degrees more timing at just 2.9% PSI, 2.9 PSI, and maybe at 10,000 RPM. We can get away with running 12 more degrees. And then maybe down here at 1,000, we'll just say we'll put 4 in here. Under higher boost levels, we're going to run less timing at the same RPM, so maybe we'll put 6 there. And then again, coming down here to maybe 1,000 RPMs, which theoretically we wouldn't be at 1,000 RPMs and 35 PSI. But if we were, let's just say we would add 2 degrees of timing. So taking these 4 points and just connecting them and doing a little linearization with the letter L, we can see that we can add more timing based on our ethanol content. So let's look at what that means. We'll have to pull these together. When our fuel composition scaler is at 100%, when we've got 70% ethanol or more in the tank, then we will take all of these values. So If we've got 100% or 70% ethanol or better, and we're running 10,000 RPM, we will add 12 degrees on top of what we've already got here at in our base table. Right? So that's how we just basically make a quick and easy composition correction based on the ethanol content that allow us to run more timing without really having to go back here and do any mucking around or changing with timing maps or making a secondary timing map, which we would do in traditional systems. So if we close up the ignition tuning and just come back over here to fuel tuning, and again, we have those corrections that we talked about. And let's see, if we start to look at our fuel composition correction, again, using the same scaler as before. So if we've got 70% ethanol or better, we're going to use 100% of this table. Here is where you can make additions or subtractions to your base fuel map. Now, theoretically, if our VE table is correct, we really should almost never ever have to make any changes here. So that's the theory. In practice, in real life, if physics doesn't apply to you, which sometimes it doesn't apply to me, you have to go in here and make some changes when you've got 100% of your ethanol content, and it will interpolate based on the percentage of ethanol that's in the tank, more or less of this value, or actually less of this value, on top of your base fuel map. So if we look at all of these tables together, it kind of works a little bit better. So here you've got your ignition fuel composition scaler for ignition, as we talked about before. This is the changes that we made in that composition correction table. So we'll get an additional 12 degrees of timing when we have 100% of this, or 70% ethanol or better. If we had maybe 50% ethanol in the tank, then it would roll down. This would probably be about 6 degrees of additional timing. You see how that works. And that's an additional timing on top of what's already here in the table. So take that 21.8 degrees that we've already established with our pump 93, add to it another 12, and that's going to be 32 or 33 degrees of timing right there. Over here on the right side, we've got our VE table for our fuel that we've already done. And again, same composition scalar table. And as I mentioned earlier, you probably would not have to make any changes here. That's the theory, and if physics doesn't apply to you, you might have to make some changes, and you could end up with something like this, so that when you're running all the ethanol that you're anticipating to run, 70% or better, you might have to be removing certain percentages or adding certain percentages of fuel to stay within your target AFRs. Anyway, all of that together is Haltech's sort of initial way of doing flex fuel tuning. So now we're going to take a stop and take a look at a different way of doing the same thing without necessarily using these composition tables. Now here in method number 2, we're not going to be using any of these compensation scalars. Are all set to 0. The compensation corrections are all set to 0. Instead, we're going to use a feature that I love in Haltech, and it is called 3D mapping. So let's say we've got our maybe our pump gas tune is done first. And by the way, with method number 2, you can do either your ethanol E85 tuning first and then pump gas. It doesn't matter which direction you want to go. But let's say we had decided for a pump 93, we had set our target lambda to look kind of like this, with values rolling into the mid-10s as we got into the higher levels of boost, and for AFR targeting. Okay, now that's great for pump 93. Now for us to go with the 85, we'd want to definitely have these values be more into the 11s, because we're going to take advantage of the increased octane level that the ethanol is going to give us. How can we do that? Well, one thing is the beauty of 3D mapping. So we look here, we've got an X and a Y axis, right? So on the x-axis, we've got RPMs. On the y-axis, we've got boost and vacuum values, and that is typical what you would see in a 2D map. However, if you go in here under table axis setup, click right here, and then we've got a third option available. So here we see one of our axes is RPM. All the values are running from 0 up to 10,000 RPM. And then we've got manifold pressure on our y-axis, with values running from minus 14.5 up to, I guess we're running about 42 psi. Yeah, 42 psi is our high end. And then we actually have a z-axis. This is our third degree of the table. And here we can use, you can select whatever you want, but here we're going to select fuel composition. We're going to put that in here. We have 0 for our low end. And as we talked about earlier, we just need to look at 70% ethanol or better as the high end. So if we get 85, 75, 95% ethanol, all of that's going to be treated the same. And once we've added these two in here and we click OK, you're going to notice a third dimension is now showing up here at the bottom of our chart. So right now we can see that when we're at this 0% of fuel compensation, we're going to run, actually I should have made that 10%. We're running this, we'll see exactly this version of the map. And when we're running 70% ethanol, we click down here, you see the little blue button came all the way down here. We're actually still running the same map, but now we can change it. Let's say we're going to drop in some new values that look more appropriate for running E85. So now when we're running 70% ethanol or better, we're going to see our AFR target's going to be 11.4, 11.3, 11.2, what have you. When we're running just 10% ethanol or less, we're going to be running values that look like this. This is how easy it is to go in and make a change so that whenever your ethanol content is 70%, it'll run this. If it's 10%, it will run this. And if it's somewhere in between, it will interpolate between these two maps. So let's quickly go in here and just fix this so that we can set that table access correctly. This should be reading 10 instead of 0. So we can go ahead and delete that value. We'll have 10 and 70. And so now the map works like this. So anything that is 10% ethanol or less will run this sort of pump 93 map, and anything that's 70% or greater will run this sort of E85 targeting map. We're going to use the same concept of this third dimension in 3 other tables. So obviously we've got our base fuel map, which is our VE map. As I mentioned earlier, theoretically, this should not have to change. It should be the same between 10 ethanol and the 70% ethanol. But as you can see, when we did this tuning, we had a few minor changes. Let's see, looking right around here, you'll see that we modified things just slightly to kind of stay within the targets of our AFR. Not much there, but a little bit, and that can happen. Where else? So once we're done with fuel, obviously we've got ignition timing. And same thing, we're going to have our base ignition timing table. Once again, we can just go here, set this up by table axis, add that third dimension, the Z dimension of 10 and 70% ethanol. Once that's in there, then we have this little feature on the bottom which helps us to get to that third dimension. So we're running 10% ethanol, we're running this kind of timing across this map, and when we're running 70% ethanol, you can see we're running a lot more timing because we were able to tune it with that knock resistance that we get from the E85 and run like that. Finally, we've got to look down here, one more table, which is really important. It's our boost table. So engine functions, boost control. We've already done all the open loop boost work, so we set up our base duty cycle table accordingly, so we knew how much duty cycle we need to run to reach our various boost targets. But the trick here is under closed loop target pressure. Once again, we'll go in and add that third dimension, the fuel composition, and that will allow us to target 2 different kinds of targets for boost pressure. So when we're running that pump 93, maybe our overall target is about 20 psi. We don't want to go beyond that. And then if we are running 70% ethanol or better, now we can target 34 psi, and the ECU will just go and get what it needs to get in terms of these targets, anywhere between there. So we're running somewhere less than 70%, but more than 10% ethanol, it will interpolate between the two. That right there is pretty much how it's done. So 2 different ways of tuning flex fuel. Choose which method makes the most sense for you. That's the beauty of Haltech. Once again, thanks guys. Really appreciate your subscriptions and watching videos. And look forward to more videos.